Algebra and Composition with Functions. First, let's talk about algebra with functions. If we are given two functions f and g with a common domain, we can define four other functions as follows. F plus g of x is defined to be the sum of the two functions. F minus g of x is defined to be the difference of the two functions. Fg of x is f of x times g of x. And finally, f over g of x is f of x divided by g of x. And the domains for all of these will be the domain of f and g, with the exception that in the last one here, g of x, of course, cannot be equal to 0. Let's take a look at an example. Here we have f of x equals 4x squared plus 3x plus 2, and g of x is 2x squared minus 5x minus 6. Write the formulas for f plus g, f minus g, f times g, and f divided by g. So first of all, f plus g, the name of the function is f plus g of x, and it is defined to be f of x plus g of x. F of x is the function 4x squared plus 3x plus 2, and we are adding that to the function g of x, which is 2x squared minus 5x minus 6. To add these functions, we just simply remove the parentheses because the parentheses aren't doing anything anyway. And then from there, we can combine like terms here, like terms here, and finally, like terms here. And so 4x squared plus 2x squared is 6x squared. 3x minus 5x is negative 2x. And 2 take away 6 is negative 4. And so in the end, we have f plus g of x is 6x squared minus 2x minus 4. Next, let's compute f minus g. So f minus g of x is defined to be f of x minus g of x. And we're just going to take the same two functions that we had a minute ago, f of x, which is this one, minus g of x, which is this one. And this time, the parentheses matter a little bit more, particularly the second set of parentheses. This negative sign is going to distribute to each one of these terms here. So if we do that distribution, the first set of parentheses can simply be removed, and then we get minus 2x squared plus 5x and plus 6. And then once again, we can combine the like terms here. And combining those terms, we end up getting 2x squared plus 8x plus 8. And this is the function f minus g of x. And it's worth noting here that if you were to do g minus f, so if you reverse these two here, you would get a different answer, right? In fact, you would get the opposite of the answer that we got here. For the next one, we have fg. Now, fg of x is defined to be f of x times g of x. And so this is the function f of x multiplied by the function g of x. Now, we actually have to multiply this out. That's quite a bit of work. So we have to multiply every term of the first polynomial to every term of the second polynomial. And when we do that, we are going to end up getting 9 terms. So let's go through this carefully here. First, we have 4x squared times 2x squared, which is 8x to the 4th power. Then we have 4x squared multiplied by negative 5x, which gives us negative 20x to the 3rd power. Next, positive 2 times 2x squared is positive 4x squared. Now we'll move to 3x. 3x gets multiplied by each one of these. 3x times 2x squared is 6x to the third. I'm going to put that right here. It's kind of convenient to line up those like terms. 3x times negative 5x is negative 15x squared. And finally, 3x times negative 6 is negative 18x. And then we have the last number here, positive 2, gets multiplied to each one of these as well. 2 times 2x squared is positive 4x squared. 2 times negative 5x is negative 10x. And 2 times negative 6 is negative 12. And then we're just going to add all these up. So we end up getting 8x to the fourth minus 14x to the third minus 7x squared minus 28x minus 12. And finally, we have f over g. Now, f over g, of course, is f over g of x. And the definition for this is f of x divided by g of x. And in this case, it's simply 4x squared plus 3x plus 2 divided by 2x squared minus 5x minus 6. And you can pretty much just leave your answer like this. Now, if you can factor these polynomials, you could attempt to factor these and reduce. But in this case, we don't get anything that cancels even if they did factor. And so this would be our answer. So in the next example, more of the same. Here we have three functions, f, g, and h. In the first problem here, we want to find f plus g, which of course means f plus g of x, which is defined to be f of x plus g of x. And that is 4x minus 3 plus 4x squared minus 7x plus 3. Combining like terms, I'll go ahead and put the 4x squared first. And then we have positive 4x and negative 7x, which is negative 3x. And finally, positive 3 and negative 3 here cancel out. And we end up just getting this here. Next, we have fh. Now, fh of x, of course, means f of x times h of x. So again, now f of x is 4x minus 3. And we're going to multiply that by h of x, which is x minus 1. And to do this, we'll simply FOIL. 4x times x is 4x squared. 4x times negative 1 is negative 4x. Negative 3 times x is negative 3x. And negative 3 times negative 1 is positive 3. Combining like terms, we have 4x squared minus 7x plus 3. Next up, we have fg. Now, fg, of course, once again means f of x times g of x. And that is going to be the function 4x minus 3 multiplied by g of x, which is 4x squared minus 7x plus 3. So this is very similar to the last problem we did on the previous page. When you multiply this out, you're going to multiply everything here to everything in the second one. So that gives us 16x to the third minus 28x squared plus 12x. And then we have minus 12x squared plus 21x and then minus 9. Combining like terms, 16x cubed, take away 40x squared plus 33x minus 9. And finally, we have g divided by f. G divided by f, of course, means g of x divided by f of x. G of x is 4x squared minus 7x plus 3. And we're going to divide that by f of x, which is 4x minus 3. And in this case, I think we can simplify, because if you look at this polynomial here, it looks like maybe we can factor it. And I'm going to guess that maybe one of the factors is 4x minus 3. So this is another way you can approach factoring, just by simply guessing. So if that were true, if 4x minus 3 was indeed one of the factors here, we know the other factor here would have to be x, because 4x times x would give us 4x squared. And we know this number here would have to be 1 because 3 times 1 would be 3. But to get positive 3, this would actually have to be a negative 1. And then you can just double check to make sure that when you multiply this, you do get this. In this case, you actually do. So this allows us to simplify our answer here. And we're going to say that g over f is actually x minus 1. Now, something to keep in mind, even though this factor went away, we still have to consider 4x minus 3. If it were equal to 0, that would give us x equals 3/4. So that's still an exclusion for this domain, okay? So the answer, yes, is x minus 1, but no matter what, x cannot be equal to 3/4, because if it is, it's going to make the denominator 0. So in the next example, if f, g, and h are the same functions defined in example 2, we're going to use the answers that we got in example 2 to evaluate the following. So to evaluate f plus g of 2, we know that f plus g of x was actually equal to 4x squared minus 3x. So when I do f plus g of 2, all I need to do is plug 2 into this function. So that is 4 times 2 squared minus 3 times 2, which is 4 times 4 minus 6, or 16 minus 6, which is equal to 10. And the next one, f times h, that function was 4x squared minus 7x plus 3. So f times h, evaluated at negative 1, would just be plugging negative 1 into x here. So that's 4 times negative 1 squared minus 7 times negative 1 plus 3. This is 4 times 1 plus 7 plus 3. And if you add these up, you get 14. F times g is this big function here. So f times g of 0 is simply going to be this function, but we're going to plug in x equals 0. And can you see that when you do that, you're going to get negative 9, right? If you plug 0 into all of these terms here become 0, and you just get negative 9 left over. And finally, g divided by f of 5 is going to be g divided by f of 5. We're just going to put 5 in there, so that's 5 minus 1, which is 4. So once you know all of these functions, it's just like any other function. You just simply replace x with the number. As an example, consider this. A company produces and sells copies of an accounting program for home computers. The price they charge for the program is related to the number of copies sold by the demand function. P of x equals 35 minus 0.1 times x. Now that P of x there is really the price, okay? And it's the price per unit, all right, where x is the number of units, okay? Now, this is called the demand function. Now, why would it be called the demand function? Well, because the price, in a lot of ways, determines the demand, right? The more you charge for an object, the less people want to buy it. The less you charge for an object, the more people want to buy it. So the price function is also called the demand function. Now in part A, it says to find the revenue function. Well, revenue means money brought in, okay? So total money collected. So let's think about this. If x is the number of units sold, then the revenue is going to be the number of units that you sell multiplied by the price per unit. So if you sell X units, you're going to multiply that by the price, which in this case is 35 minus 0.1 times X. And if you multiply this out, this is 35x minus 0.1 times x squared. And this is often what we call R of x, which represents the revenue function. So this means if you sell a particular number of items, all you have to do is plug in that number X, and it will tell you the revenue that you will collect. So just a quick example of this before we go on. If X is equal to, say, 20 units, the revenue you're going to get from selling 20 units will be 35 times 20 minus 0.1 times 20 squared. 35 times 20 is 700 minus 0.1 times 20 squared. 20 squared is 400. This is going to be 700 minus 40, which is 660. And we'll assume that this is dollars. So if you sell 20 units, the total amount of money that you're going to collect is $660. Now for the second part, part B, it says, if the cost function is 8x plus 500, find the profit function. Okay, the profit is the money that you make, right? It's the total money after you pay your costs. So profit is revenue minus cost. So it is simply R of X minus C of X. Well, R of X we now know is 35X minus 0.1 times X squared. And we're going to subtract C of X, which is 8X plus 500. So if we do the math here, we have 35X minus 0.1 X squared minus 8x minus 500. So don't forget, you have to distribute the negative here. And if I reorder this, we have negative 0.1 x squared plus 27x minus 500. And this is what we call capital P of x, which stands for the profit. So this will be the total amount of money that you profit when you sell X units. The thing to notice here is that we are subtracting two functions, and that's why this is in this section, right? Because it fits with the algebra of functions. Now let's talk about compositions of functions. So what is a composition? Well, a composition, the technical notation is this notation. And so this symbol here is not the letter O, it's the composition symbol. And the best way that I can describe it is that it looks almost like a degree symbol, like when you say the temperature outside is a certain number of degrees. So the way we say this is the composition of the functions f and g. What it means is the following. It means this, f of g of x. So we're plugging g of x into f of x. So how does this work? Suppose you pick x is equal to a number. That number is first going to go into the function g of x, and then that answer is going to go into the function f of x. So the way this works, if I have a domain here, if I pick a number x, first we are going to apply the function g to that number, and that's going to give us a new number, g of x, and then we're going to apply f to that number, and that's going to give us another number called f of g of x. And so the compositions of functions is just a way to do a shortcut so that when I plug in a number x, it goes straight to the end result. Let's consider a couple of examples. So here we're given two functions, f and g, and we want to find f of g of x, which really just means this. And then second, we want to find g of f of x, which means this. So in the first one here, f of g of x, what we're doing here is we're taking the function g of x and we're plugging it into f of x. So quite literally, we're taking g of x and we're putting it in here. So this is simply going to be g of x plus 5, right? If I plug g in for x there, that's what we get. But we know g of x is x squared minus 2x. So this becomes x squared minus 2x plus 5. Right? And this is the function f of g of x. For the second part, g of f of x, we're just doing the reverse. Now we're taking f of x and we're plugging it into g of x. So I'm going to replace x in both places here with f of x. So this becomes f of x quantity squared minus 2 times f of x. But we know what f of x is. F of x is x plus 5. And so this becomes x plus 5 squared minus 2 times x plus 5. And then if we multiply this out, of course, this is x plus 5 times x plus 5 minus 2x minus 10. And if I FOIL here, we get x squared plus 10x plus 25 minus 2x minus 10, which simplifies to x squared plus 8x plus 15. And of course, the thing to see here is that in general, f of g of x is not the same as g of f of x. And so now you just need to make sure that you get enough practice. It's not as bad as it looks once you get used to the concept here. So make sure you spend some time and get a little bit of practice. And that concludes this video lesson.